In 1970, a psychologist named Walter Mischel sat a 4-year-old child down at a table at Stanford University, placed a single marshmallow in front of them, and left the room. The deal was simple. You can eat this marshmallow right now, or you can wait 15 minutes, and when I come back, you get 2 marshmallows. Most of the children ate it, not after a long internal struggle, not after carefully weighing the long-term benefits of patience against the immediate pleasure of sugar. Most of them ate it within minutes. Some ate it within seconds of the door closing. And here is the first thing the brain science actually tells you about this. Those children were not failing at self-control. They were doing exactly what a human brain, running on 50,000 years of evolutionary hardware, is built to do. The brain does not hate waiting because it is weak. It hates waiting because, for most of the time humans have existed, waiting was genuinely dangerous. The animal that waited for the berry instead of eating it now risked finding no berry later. The animal that stored energy instead of using it had less energy for the fight that arrived tomorrow. The brain that evolved to prioritize immediate rewards over uncertain future ones did not produce stupid animals. It produced animals that survived. You are descended from the ones who did not wait. Now sit with that for a moment, because it means the part of your brain that cannot watch a progress bar without opening a new tab, the part that refreshes the same web page 17 times waiting for something to load, the part that loses patience in the first 3 minutes of a queue and starts calculating which line is moving faster, is not a character flaw. It is a 50,000-year-old survival instinct that has been placed slightly uncomfortably inside a world full of progress bars and loading screens and queues. The neuroscience of this is specific. When you wait for something you want, 2 systems in your brain are running simultaneously and they are running in direct opposition to each other. The first system is centered in the limbic region, particularly the nucleus accumbens, which researchers at McGill University identified in 2015 as a critical structure in delayed gratification decisions. The nucleus accumbens is your brain's reward center. It runs on dopamine, and it is not interested in later. It responds to what is here, what is visible, what is available right now. When a reward is present, this region activates immediately, urgently, with the particular energy of a system that evolved before the concept of tomorrow existed. The second system is centered in the prefrontal cortex. This is the region responsible for planning, self-regulation, reasoning about future consequences. It is newer, evolutionarily speaking. It is also slower. When you decide to wait for something better, your prefrontal cortex is winning a competition against a system that has been doing this for far longer and cares considerably more. The McGill researchers demonstrated something specific about this competition. When they disrupted the connection between the hippocampus, the brain's memory and future planning center, and the nucleus accumbens, rats became immediately and completely unable to wait for better rewards. They stopped choosing the larger, later option. They always chose the immediate one, regardless of how much smaller it was. The circuit connecting memory of the future to the reward system is not a metaphor for willpower. It is a literal physical pathway, and when it is severed, waiting becomes, in the most biological sense of the word, impossible. There is a second problem the brain has with waiting that most people have never heard of. It is called temporal discounting. And it is the reason your brain does not just dislike waiting, it mathematically undervalues the future. Every time your brain considers a future reward, it does something that no rational calculator would do. It applies a discount rate to the value of that reward based entirely on how far away in time it is. A reward available now is worth its full value. A reward available in a week is worth somewhat less. A reward available in a year is worth considerably less. Not because the reward has changed, and not because you have thought about this and decided it is lower priority. Your brain simply treats future things as worth less than present things by default, automatically without your input. This is called hyperbolic discounting, and it is not unique to humans. It appears across species, which suggests it is not a cognitive error so much as a design feature. The future is uncertain. Things that are promised to you later may not arrive. The brain that treats future rewards as slightly fictional is the brain that does not overcommit to outcomes that may never happen. But here is the specific part that gets genuinely strange. A Stanford researcher named Hal Hershfield ran a series of fMRI studies comparing how people's brains respond when they think about their current selves versus their future selves. The finding was this: the neural pattern your brain produces when you think about your future self is almost identical to the neural pattern it produces when you think about a complete stranger, not a close friend, not a family member, a stranger. The participants in Hershfield's research who showed the biggest difference between current self and future self brain patterns, the people whose future selves looked most neurologically like someone else entirely, were the least patient in financial decision-making tasks. They were the least willing to wait for larger rewards later. They consistently chose smaller, immediate gains over larger, delayed ones. As Hershfield put it, why would you save money for your future self when, to your brain, it feels like you are handing your money to a complete stranger? This is what temporal discounting actually is, at the neural level. It is not that you have consciously decided the future matters less. It is that the future the person who will receive the reward, the person who will benefit from the waiting, does not feel fully like you to the part of your brain making the decision. It feels like someone else, someone you may care about in a vague, abstract way, the way you care about strangers, but not someone whose well-being you would sacrifice your present comfort for. Now here's the part that reframes the Marshmallow Experiment entirely. In 2018, a replication study used over 900 children from a far more diverse socioeconomic sample than Mischel's original. The correlation between waiting ability at age 4 and life outcomes at age 15 was dramatically smaller than in the original study. And when researchers controlled for family background and socioeconomic stability, the correlation shrank further still. What the larger study suggested was not that self-control does not matter. It was that a child's ability to wait for a second marshmallow is, to a meaningful degree, a measure of whether that child has learned from experience that waiting actually pays off. Children raised in environments where promises are kept, where resources are stable, where the future reliably delivers what the present delayed, learn to wait. Children raised in environments where promises are broken, resources are unstable, and waiting has historically produced nothing, learn that the marshmallow in hand is the only certain marshmallow. This is not a failure of willpower. It is rational updating on available evidence. The dopamine story is more complicated than you have probably been told. Most people believe dopamine is the pleasure chemical. You feel good, dopamine fires. You enjoy something, dopamine rewards you. This is close to true, but importantly wrong in the way that matters here. Dopamine does not primarily respond to pleasure. Dopamine responds to anticipated reward. It fires not when you get the thing, but when your brain predicts that the thing is coming. This distinction is crucial because it means dopamine is not the enemy of waiting. It is, under the right conditions, the engine of it. A study published in the journal Science Advances demonstrated this directly. Dopaminergic neurons in the ventral tegmental area showed a steady, sustained increase in activity throughout a waiting period in mice trained to wait for a water reward. The dopamine did not spike at the reward and then fall away. It ramped up continuously across the entire waiting period, building rather than depleting. This sustained dopamine ramp appears to be exactly what allows the brain to keep waiting instead of giving up. The dopamine, in other words, is what makes patience neurologically possible. The University of Cologne confirmed this with human participants. Researchers administered L-Dopa, a precursor to dopamine, in a large-scale double-blind study published in the Journal of Neuroscience. Those who received L-Dopa were approximately 20% less impulsive than those who received a placebo. Their dopamine levels, modestly elevated by the drug, made waiting feel more sustainable, more connected to a future their brains could take seriously. 20% less impulsive from a single dose of a dopamine precursor. That number sits differently when you realize it means the difference between your best intentions and your worst habits might partly be a conversation happening in your midbrain that you have never been consulted about. Here is what the research actually leaves you with. Your brain hates waiting not because it is irrational, but because it is running a very old program on a very new landscape. The limbic system that pulls you toward immediate reward did not evolve for a world of loading screens and delayed shipments and retirement accounts that mature in 30 years. It evolved for a world where the future was genuinely uncertain, resources were genuinely scarce, and the gap between now and later was frequently the difference between surviving and not. The future self that would benefit from your patience does not feel fully like you. The dopamine that sustains waiting requires genuine belief that the future will deliver. The circuit connecting memory to reward is a physical pathway that can be disrupted, and a child who cannot wait for a second marshmallow may simply have a nervous system that has learned accurately that waiting is not reliably worth it. Every time you lose patience with something that is taking too long, some part of your brain is doing what your ancestors needed it to do. The frustration is not a malfunction, it is the system running correctly, in a context it was not built for. The same dopamine system that makes waiting hard is also what makes waiting possible. Give your brain genuine reasons to believe the future will deliver, real evidence that the promise will be kept, that the reward will arrive, that the future self who receives it is actually you. And the system that pulls toward immediate reward becomes the system that sustains patience across time. Your brain does not hate waiting because it hates you. It hates waiting because it loves you, in the only way an ancient survival system knows how. It is trying to protect you from a future it cannot fully see. The problem is that the future has gotten considerably more complicated than it used to be, and 50,000 years of instinct is still catching up.